Here we want to use a linear approximation or differentials to estimate the given number. So if we look at the number in front of the decimal point, which is 2, we're going to let a equal 2. Okay, so in order to let a equal 2, then what that tells us is we're going to be able to write out what the linearization is going to be. So L of x is going to equal f of 2 plus f prime of 2 times x minus 2. So now we need to look at a function. So what is the function? Well, the function is that if x is equal to 2.001 and that's raised to the fifth power, that means f of x is going to equal x to the fifth. And if we want to find the derivative of that function, f prime of x is going to equal 5x to the fourth. So what we want to do is we want to find f of 2. So if we plug 2 in and raise it to the fifth power, 2 to the fifth power is going to give us 32. And then in step 4, or f, not step 4, but just f prime of 2 is going to equal 5 times 2 to the fourth. And that's 5 times 16, which is equal to 80. So now in step 4, we can now write that linearization using the given information. So L of x is going to equal f of 2, which we found is 32, plus f prime of 2, which we found to be 80, times x minus 2. If we distribute the 80, we get 32 plus 80x minus 160. And therefore, L of x is going to equal 80x minus 128. Okay, so we want to determine the fact that x to the fifth, in this case here, x to the fifth is approximately the linearization 80x minus 128. And that is when x is near 2. So we know that the value of x is 2.001. So we're going to plug that in for x, and we're going to get 80 times 2.001 minus 128. So that gives us approximately 160.8 minus 128, which gives us a result of 32.08. So let's check our result on the calculator. If we take 2.001 and then raise it to the fifth power, then we get approximately 32.08, and by using the linearization function, we were able to plug that number in to get the actual number of what that would look like as we plug it into our calculator.